Hi, Victor. Why hasn't anyone done this yet?
In very short words, it's a hard problem, right? You might imagine that the world of AI generally, and we were very, very, very early in the world of neural networks, and it's largely built on transactional and pretty easy to read, like computer to read data. So tabular data is awesome for this. You imagine all the spreadsheets in the world, you can suck that up in a computer very easily and give it some kind of treatment and apply some methods to it, and you get to an AI model. That's pretty easy. Another input may be images and video, but those all need to be pre-processed. So just giving an image to a computer doesn't really give you anything. It's a file. That's all you really know until you do some pre-processing, just like a video is. So in order for the computer to understand that better, there are treatments that you give to images and you give to videos. And that's a very common thing because there are competitions for that. Now, the world doesn't do quite as well with text, and it's gotten better recently. It's more of a novel problem than the image and video because a lot of people are trying to solve the image and video, whereas the text one isn't as fun of an academic problem usually. So it leads to there's not as many hands on it, right? In order to get to a world where you can build an AI program, you're going to have to build up your internal capabilities and knowledge because you're dealing largely with unstructured text. So just like we were saying, images and video, those are definitely unstructured, but you can structure them by pre-processing. In text, you can do the same. You can turn extremely large pieces of content, whether they are legal decisions or Shakespeare or whatever, like a huge work of literature, you can turn all of that into something that the computer can use. And you do that with NLP and NLG, and that pre-processes, and then you'd be looking to pass it off to some AI program to whatever it is that you need to do. You could do all kinds of things in AI, but you could generally predict or cluster things. Those are the two big buckets, right? So now that NLP and NLG are the things that are going to get used, so you're going to need people to do this. So let's park that caveat all to the side. You're obviously going to need the right people for this. You're going to build a specific model for the language that your program is looking to dissect. In this case, cases and decisions, legal matters, whatnot. So you're going to have to do a lot of pre-processing and do usually a lot of manual labeling yourself. So there's a lot of just work to be done. Once you've done a lot of this manual labeling and pre-processing, you're then going to build that language model. So if you remember last time we talked about PHYLAC and our version of PHYLAC, which is an improvement, so our PHYLAC+++, where PHYLAC stands for facts, issues, laws, analysis, and conclusions. And the rest of the characteristics of a legal case that we also see and we also classify, we can't really talk much about them, but there are several others. That then leads to you now have the ability to turn this large unstructured piece of text into a more structured data set for your computer to use. So now you could imagine that, let's say it's a 10-page notice of some sort. You could run that through a pre-processing and you would know each individual article in there or each paragraph, what their intent was, whether it was a fact, a conclusion, whatever. And then you could also from there pull out other information about the entire case, and you would build a representation of that case in a way that a computer wants it for AI. And then, of course, there's the hard work of making AI. So, yeah. So the language model really is key. And that's usually the big reason is the pre-processing and language model that's required for this. Because if everyone just has that input to an AI model, it becomes easier.